Okay, having a wee look at these ones here. Unit vectors. So you need a hat equals your vector divided by its length. So you've got to find its length first. So that's Pythagoras' theorem. 2 squared add 1 squared square rooted. Now you can write it as 2 over root 5 and 1 over root 5, or you can write it like this, or you can write it as 2 over root 5i, make sure you underline the I, plus 1 over root 5j. It's just your own choice. So B and C just follows from that. Question 2. Now, if you look at question 2, O to A is a small A underlined. They've done it in bold. O to B is B. O to C is C. I want A to B. So remember, it's going to go, you see it better in the picture, A to O, then O to B. So it's minus A, add B. A to C, similar. A to M is half of A to C, so just half it, and O to M. You'll go O to A, add A to M, and just fill in all your bits and pieces. N to M, go through O is usually the easiest. So N to O, and then O to M. And just filling in your wee bits there. And O to N equals O to M, so just put them equal to each other and you get that wee equation. Hopefully that one's not overly bad. Question 3, the parallelogram. Right, it's a bit of a mess here. Hopefully, if I talk you through it, you'll be able to see what I'm doing. A, B, C, D is your parallelogram. The position vectors come from O. So O to A, see there? That is your vector A. O to B is your vector B. O to C is your vector C. And O to D, you have to find it. So O to D, I can go O to A and then A to D. Okay? And I'm just checking here. Yeah. So O to A is A. Now you see A to D. It's going to be the same as B to C. So how can I get B to C? I can go B to O, which is minus B, plus C. So it's just playing around with the wee paths that you have there. Now, I want A to D. Oh, sorry, that was just me, explaining that there, over at the side. Okay, what have we got now for number 4? There are different ways of doing these, so if you've got a different way and it works, don't be thinking that, if you get the same answer, that's grand. So, they give it to you in coordinates. This is me giving it as position vectors. So to get from O to A is 2, 3. O to B, 5, 7. So it is important you write them as position vectors. A to B, I'm going through O. You can put the wee O in there if you want. It's A to B is going to be AO plus OB. So it's backwards OA plus OB. Working that out. Then they want A to L, which is half A to B. Then it wants O to L. So start at O, end with L. I'm going through A. So O to A, you know. A to L, you know. Just add them together. B to C is B to O plus O to C. So B to O is backwards, O to C is forwards. To tidy up. B to M is half of B to C. O to M. So look, I went through B. So OB plus BM. Okay. Question or part 2, A to C. So A to C, I'm going to go AO plus OC. It's the same kind of thing each time. OA plus OC. So that's backwards and that's forwards. L to M, going through O. LO plus OM. Just put in your big bits and pieces. The length of AC, remember your Pythagoras, so 10 squared at 5 squared square rooted. The length of LM, Pythagoras again. Now, if you look at LM, it is half AC. And if you look over here, your vector LM is half your vector AC. So they are parallel. It's going the same direction. And LM is half AC.